Welcome to another tutorial video of the Digit Management System. In this video, we're going to show you how to use a feature we call stacking to turn CSV files into a three-dimensional relational database. Now there's a website called Kaggle where people upload various data sets. I like to use various data sets on that site to test out my system. So one of the data sets out there, someone used the Spotify API to download information on hundreds of thousands of Spotify music tracks. And so I just went out there and downloaded the CSV file. If I bring it up in my Notepad++ editor, you'll see there's about 20 columns in this. It's got an ID, the name of the track, how popular it is, etc. Two of the columns, one called artist and the other is the ID of those artists. It represents in sort of an array here because they want to be able to allow multiple values. So a song might be sung by more than one artist. So they're going to put each of the artist's name and their ID in there. If we come down here to line 38, you'll see that. Here's a song with three different artists, one being his orchestra, and along with their three IDs. Same here. There's another one. So previously I created a definition by just dragging and dropping this CSV file into the definition window, and then went and modified a few things for which columns were integers, which were doubles, and left the others as strings. So I have a definition all ready to go here. So if I take that CSV file and simply drop it on my definition, it's going to import and create me a tracks table in here. There's several hundred thousand. It takes a minute to download everything. So now I've got this nice little table with almost 600,000 tracks in it. If I just double click on it, there they all are, and you'll see in the artist column here there's multiple values. And we like to do analytics against things, and it's harder to do when your artists are out in an array like this. So what we're going to do is stack these up so we can create a three-dimensional aspect to the artist and the ID artist columns, so we can do better analytics. So first thing we need to do is get rid of these brackets. So we have a little transform function here we call trim single. So this will take the brackets off of both ends of all the values in here. So I changed 113,000 different values. Now we don't want to take off the quotes here until we've stacked things up. Otherwise it would just take off the beginning one and the end one and leave everything in the middle. So what we want to do is right click on here, and we're going to stack the values. And you can see that the delimiter, they have a comma and then a space and then the next bit. So I'm going to specify the comma plus a space, say OK, and it's going to parse out and stack up. Found 53,000 values and split them, so about an average of 3 values in each one of those that were split. So click OK. So now you see my artist column has brackets around it, meaning there's a three-dimensional. And sure enough, here's one that is 3 layers deep. If I just double click on that value, it'll show me the values, and they still have the quotes around them, so we can get rid of those quotes now. We're going to transform and do like we did with the brackets and trim the single. And now I've got all the artists, including some with this third dimension. Now let's say I only want to look at rows that have a certain depth to them. So we're going to apply this levels filter here, and we're going to only show rows that have at least, say between 6 and 10 artists in them. So here we go. Now here's the artists. This one has 10 artists. This one has 6. That one has 8. So let's pull one up that has 8. You'll see this one has Mozart and Berlin and a bunch of other people no one's ever heard of. So let's say we wanted to filter, and we want to see all the rows where Mozart was in there. So we're going to say we want to go off the and it contains Mozart. We'll filter, and for those that had 6 to 10, each one of these should have Mozart in them. So we have 162 tracks. If you look at the names of them, you'll see a lot of Mozart tracks in here. And sure enough, if we come over to here, we'll see Mozart in all of them. There's one there. Again, he's the most popular artist of these that are stacked so deep. So we can do analytics based off of the artists. If we want to see, back at the main thing, we don't care about depth. We want to look at just the songs where the artist equals Elvis Presley. Filter them, and sure enough, here they are. There's the 695 tracks that Elvis sang. Now, if we want to see just the ones he did with other artists, we can again apply the filters level. So we only want to see those that are a minimum of 2 deep. So here are the 15 songs that Elvis sang with somebody else. Looks like they were all just one other artist in all of these songs. There's one from Tommy Dorsey. This one had the Jordanaires. If you want to see all of them, we just show the column values. You'll see Elvis is in all 15 tracks, but the Jordanaires were in 7 of them. Tommy Dorsey was just in 1. The Amigos, the Philharmonic Orchestra. So you can see we can create this 3-dimensional table by stacking the values in any given column that has multiple values in the form of like an array. So unlike JSON, CSV files don't really let you do arrays in a traditional sense. You have to kind of trick it like they did here with the tracks API, in that they enclosed it in quotes and put them in brackets and separated all the values by commas. But using our 3D technology, we can turn it into a regular relational table that we can do queries on and show you analytics very quickly. Thank you very much.